that fit multiple categories? How does that work with ratios? So generally, like the way that we're going to be using ratios is like distinct categories and not having overlap. So I'm going to have to think about that. And evidently you are too, because nobody had a great immediate response. Okay. So what can we do to kind of practice and build up some fluency with this? Yes, what were you going to say, Thiva? Uh-huh.
I think we would have a new category. Go with the grass and
Okay.
so that the total is added to
Oh, let's write that down. Thiva just said something. She thinks there's a rule that ratios have to follow. So I'm going to write that down and remember that and see if I agree with it as I learn more. Okay. Thiva, what did you say has to happen?
So for you, there would be a new category, which is both the grad student and the team lead.
Okay.
So if you added all the numbers,
Mm-hmm.
you get the number of people.
It should match the total quantity. Is that fair, Thiva, for what you said? Okay. Any thoughts? Yes.
I disagree.
Okay.
Just because in that eyes people say it's important, but
Eyes to people is a part to whole.
no. But like if we have two eyes and one person and then we add them up, that would have 3 people technically.
Oh, so that doesn't fit if it's a part to a part that aren't.
Or non-exclusive.
So can I be an I and a person?
No.
So are those
The eyes are all
exclusive? All right. So they are exclusive then. So I think the question is, can elements of your ratio be
For like
inclusive?
the boys one, it would work.
Okay.
If you would have 1 to 8 and that would be 9.
Mm-hmm. Okay, but if my ratio was 1 to 9, and I'm representing part to whole, then I wouldn't add them up, right? Or if it's coins compared to how much the coins are worth, I wouldn't add those together. Yeah.
I feel like though, if you have a problem statement and it does mention the number of holes, and then if that ratio you add it all up, it's like equals that, then maybe that's not. But unless it doesn't say that, you don't.
Okay. Yeah. So if I just provided this information, it doesn't tell me if I brought my kid to school today, or I brought my kid with me to work and they're sitting in here. So there could be something that's not included in those categories unless we're told that it's not. Okay, awesome. So it's really important to understand what those terms are. And when I still am hearing you guys say that those terms have to be distinct, like there shouldn't be like blurriness between the different terms. Like it could be here or here. It should be distinct categories, but we'll see if that's always the case. Maybe we'll see. We'll explore that idea. We are going very slowly, everyone. Okay? There's so much more great stuff to get to. So this is just a kind of gamifying way of practicing. I trust that you can read that and figure it out. So I'm gonna let you do that. It's another way, kind of the opposite of you. This one you create a ratio based on what you spend. This one you represent the ratio that you roll. So it gives you the ratio and you represent it in different ways. Okay, so ways to build flexibility and fluency. You can do what we did, look around the room for some comparisons you can identify using ratios, use your manipulatives, use your use anything around you as an example of ratios. Okay, we talked about things that are visible immediately, but I would like for you to brainstorm for a moment about ratios that might not be like visible in the classroom, but might be interesting or relevant to students. Ways we use ratios in our lives. Okay, so I'm going to write down your ideas. Okay. Oh, come on, guys.
I would say one the ratio of the colors.
Okay. Ratio of colors. Well, I'm thinking starburst because I do not like yellow starbursts. So those are worthless to me. Okay. Something super relevant to your students, maybe? How about wins to losses? We use ratios in sports all the time. Okay, that's a big part of the way we keep track of sports. Yes. Okay. I would be very cautious about that. Some students would surprise you, might feel uncomfortable in a situation. Yes. Oh. So JV versus varsity games ish. I was thinking about like my mind went to like electoral votes and like the whole speaker of the house thing, like how many voted for what's his name and how many voted for what's his name. That was a ratio that showed you this part versus this part. So you could talk about votes. Yeah. Okay. Nice. Okay, we can add more to that. I might have you guys, if you think it's, instead of just asking you to write it, you can just come up. Okay. So we want it to be rich in math thinking, but also want it to be relevant and connected to their lives. Okay, so phase one, understanding. I can describe the purpose of a ratio, how it's the same and different from a fraction. I can describe a ratio in the terms, what's being compared, and the type of relationship it is. So part to whole to part to part. Those things. Correctly and confidently identify ratios given terms. And then not just thinking about the content, but the processes, the way tutees are engaging with the ideas, not just the stuff of it, but the how. Okay, you can see this. So, expressing ratios. Kayla's trying to get better about her water intake, and she's decided to drink 3 bottles of water for every 2 cans of Dr. Pepper. How would you represent this visually? How could you represent this symbolically? So since we had that quick look with counters, I think counters would be a great place to start with this. Okay, so what would that look like with counters? Can somebody describe how I might draw that with counters? Okay. Let's see. Okay. You guys okay with that? The counters as representatives for the different parts. We'll start with water. Yeah. Water. And Dr. Pepper. Okay, so I can see the 3 to 2. Okay, how can I represent it symbolically? Represent it this way, 3 to 2. Or I can represent it using the same notation as a fraction, but I need to know what those terms represent. Okay, if this represents what Kayla drank each day, she stuck to her plan, used counters to model what she's had to drink after 1 day, 2 days, 3 days. Make sense? So this is day 1. What would day 2 look like? What would day 2 look like?
So my question
Mhm.
is, are we accumulating?
Mhm.
But it could
Yes. Yes. So after 2 days, what has she had to drink in total? Okay. If she sticks to her plan. Yep, and we can keep going, right? Day 3. So even though she's by this time had a lot more waters and a lot more Dr. Peppers, the question is, do they compare the same way that they did on the first day? Is the comparison the same? So what do you want your 2 T's to be able to explain or justify with that?
Simplifying ratios,
Okay, tell me more.
because numbers are increasing every day, but overall the ratios will be the same. For example, 3 to 6 to 4 million.
It can be symbolically, I know that, but conceptually, I want my 2 T's to have the chance to figure that out, right? So you said they're changing the same way each day, something like that?
Yes.
So are they increasing? The same way each day. I think that's a key understanding, is that Dr. Peppers always increase at this rate in comparison to these waters that always increase at this rate. Like they're changing the same way in relationship to each other. Okay, so we can ask them then to create a table that shows after 1 day, after 2 days, after 3 days, and so on. And if we tally up our drinks during the week and Kayla has had 24 bottles of water and 10 cans of Dr. Pepper, what would that look like? And how would that compare to her goal? Okay, so I have my 24 waters and my 10 Dr. Peppers. How does that compare with what she planned to do? Okay, so 24 bottles of water compared to 10 cans of Dr. Pepper. How does that compare? Did she stick to her plan?
No.
No, okay. Can you justify why? Sorry.
I guess the ratio, but
It's not the same ratio?
yeah, we were simplified to the things too.
She drank more water than she planned on.
Okay. Okay. So if I continued, and again, I'm not trying to teach a procedure for simplifying the ratio yet. That's going to be more next week. What I can do is compare what I figured out so far with what I have here. So if she stuck with her plan, when she got 24 counters here, how many counters should she have here? And how does that compare to this?
She should have had 16.
Okay, so if I kept going with my counters, if I kept going with my numerical pattern, when this is 24, this is not 10, it's 16. So what does that tell me about her plan compared to her intake? Does that make sense? I'm not trying to teach simplifying ratios yet. I'm trying to see if they can extend the pattern and then identify if this ratio is true of this scenario or not. Okay, so some questions to make it rich without going just farther into the concept. What patterns do you see in each of the number values? Can you interpret what these different ratios mean for Kayla? So if I just pick this, what does this mean? Like translate it back to the context. If I pick this, what does it mean? Translate it. Okay, so those questions to try to make it richer. Okay, let's use a dash. I probably should have like not let you see that first. Okay, this diagram is what does it remind you of? What do you notice or wonder about it? What does it remind you of? What's that fraction title? Yep. Okay, so a tape diagram generally shows the whole and a part and a part. A lot of times you'll see the whole separate if something is missing. So a part and a part together make the whole. In this case, this tape diagram shows how many parts of one thing and how many parts of the other. So for Kayla's plan, right, we would need to show how many Dr. Peppers and how many waters she drank for her ratio. 1, 2, 3. So these would be waters. These would be Dr. Peppers. That make sense? Okay, representing it in a visual way, this seems, I don't know, what are your reactions to this? For every 5 miles I run, I walk 2 miles. So write that as a ratio, 5 to 2, right? I can show how far I went using the diagram. Which part of this shows running and which part of it shows walking and which part of it shows the total. Can you see all those things there? Okay, so using a diagram lets me see how the parts relate to the whole. Okay, so now that I have this information, is there another way I could have described my plan besides saying for every 5 miles I run, I walk 2 miles? Is there another comparison I could make? Okay, that's the same relationship, just expressed a different way. Is there another relationship that I could use to describe my plan? Okay, I can see that here. For every 2 miles I walk, I run 5. Thank you. Is there another relationship I could say?
I run 3 miles, 1 mile.
Oh. And then it repeats? Interesting. So I could like scooch this over. Okay. Run 3, walk 1. Run 2, walk 1. Interesting. Okay. Yep. About out of every 7 miles I go, 2 of those are walking. Or out of every 7 miles I go, 5 of them are running. Okay, so I can use the diagram to describe more relationships. How is this plan the same and different? For every 3 miles I run, I walk 4 miles. Okay, so one goal of this is to make the connection that Zoe made. This kind of reminds me of fraction tiles. Hi,
Can I say 5 to 2 to 7?
can you? Part to whole? Can you, Christina?
I don't know. I'm quiet in the Zoom. No.
I don't think so, because you already have like categorized those as something else. You're gonna add another variable and so,
Oh, so you're saying because they've already been assigned to one chunk,
yes.
my 5 and my 2, I can't use it as a 7?
I think you can.
But you can do 5 to 7, part to whole.
What if you just label it right?
What if you just label it right? Is there a rule? Yeah, Thiva.
So by representing the number of months that I ran and the months that I walked, I'm also representing the months that I covered.
Okay.
So I don't think it's necessary to represent.
It's overdefined as well.
Okay.
And someone who wouldn't say it's not variables like running and walking and total distance goal. If it's something more like X, Y, Z, X plus Y should X Y plus Y plus Z should equal to a whole thing.
Okay.
Also, again, I haven't looked at the slides ahead of time, but the one that you see the most is about lemonade. Is that on your future slide?
We have next week, we're doing more recipe things.
Okay, because a lot of the practice questions that they'll see from their teachers are making a strength of lemonade for 1 cup, because they make the one perfect cup for themselves, but now they need to make it for like all 24 classmates.
Yeah, that's next week.
So if you're looking for extra stuff for next week, make a recipe.
Yeah.
I'll take it easier.
Okay. This also gives them the chance to say, if I run 8 miles and walk 2 miles, I can show that as 8 to 2, or I can make fewer pieces. I can take that same model. Let's see, 8 to 2. Or I could say the same relationship represented as 4 to 1. Right? So I could take those 8 small pieces and turn them into 2 pieces. Then I would run 4, walk 1, run 4, walk 1, and I'd get the same result. Okay, so could I show this ratio using smaller numbers in my terms and keep the relationship the same? What other ratios could I use to describe my plan? So make it connected, some strategies for connecting it to their lives. What about you? What are your experiences? How could we represent you in ratios? Okay, we are like going super slow. So another model that might be more helpful for different situations. This is a very relevant example of ratio, spending and saving. So kind of budgeting, right? Like I spend this much, I'm going to save this much. Spend, save, and try to keep that constant. So Randall made the decision to save money every time he spent money. What values could be used to create a ratio? So what would the terms be that we could compare? Spending to saving, or spending to total, right? Saving to total, and so on. So if Randall decided that for every $6 he spent, he would keep back 3, he'd save 3. Okay, that's a plan. He wants to stay constant with that. So we can take his plan and extend it farther. So we're going to use number lines, and on your whiteboards that you have access to and your number line board, you should have at least one place to do this. 2 number lines that are parallel. Yes, do we all have that? We have 2 number lines that run parallel to each other. If not, we'll get you a whiteboard that does, or a number line board, okay? Okay. So I can use 2 number lines to keep track of what's happening with Randall's money. Okay. So up here, I'm going to keep track of what? What do you think? What am I keeping track of?
Money expense.
And here I'm keeping track of. Nice. Okay. So I want my 2 T's to notice some things about the pattern of numbers that he's spending and the pattern of numbers that he's saving. There's some valid conversations to have here. So what do you notice about the values of each number line? How do the numbers compare to each other, right? So the relationship between how much he spends and how much he saves, how do they compare? So if I keep going, what do you hope your 2 T's will notice or think about with this one? What opportunities? The rate at which they're increasing. Awesome. That big idea that Osmine said earlier. Go ahead.
I was just gonna say, because it's the kid or whatever is spending more than
Oh, okay, so will the amount that he spends always be more than he saves? Okay, how much more will it always be? Yeah, yeah. Okay, so can I identify that relationship, that it's not $10 more every time, it's not $3 more every time, it's double. Like that's a multiplicative relationship, not an additive relationship. So the relationship between them is a scale, it's multiplied by something. Okay. So these go by 6s. So when I get to, I'm gonna break, when I get to 54 here, then what number will match up with 54? 27. Why? Have a conversation about why and what that means if those two numbers match up on the number line. What does that tell us? Okay, what are some other values that would match up on Randall's saving plan? So I might just identify some that I said 3, 12, 15. Nobody said anything. Okay, 3, 6, 9. There we go. Okay, so what does it mean when numbers match up? Okay, the ratio is the same, yes? What? It's proportional. Okay, nice. So those ratios have the same relationship. So we say they're proportional. Yep, we're just gonna pretend. Okay. So that's where we can introduce that idea, or it's an opportunity to talk about that idea. Okay. What are some values that would be farther down the line? Can your tutor extend that thinking beyond what they've mapped out? And also, can they extend that thinking to what about between intervals? So if I matched up 9 as halfway between here, could I figure out what would match up here? Okay. So numbers that match up on the number line, to do that, I'd have to cut this in half, cut that in half the same way so they'd still match up. Okay, so place the values 35 and 13. Those are just examples on your number line. 35 would be ish. I took out all my specifics. 13 would be somewhere around here. Are those gonna match up on my number lines? Okay, so I can visually see that ratio is not matching. Just like with the counters, I could visually see that 24 to 10 is not the same as Kayla's 3 to 2 plan. 35 to 13 is not the same ratio because on the number line, they're in different positions, relative positions to each other. How does that plan compare to Randall's, or how does those values compare to Randall's actual plan? Make sense? Here's a similar context. I'm burning up now. Similar context, but now we're looking at a different rate of increase. So how are those values going to compare? So it gives us a good comparison contrasting opportunity. I picked 50 cents. So Lene is going to spend $6, save 50 cents. Spend $6, save 50 cents. Okay, great comparison opportunities, right? About the rate at which she's saving. And as you go farther and farther down the line, how that compares to Randall's plan. That's an interesting conversation. But I also thought it was valuable to put the cents in there because it's not it's the relationship between them. And we know that ratios, we could say 6 to 3 and be talking about cups. Or we could say 6 to 3 and be talking about gallons, and it would have the same relationship as long as those units remain the same from here to here. Okay. Here's a more physical version of the same thing. the ladybug takes 4 steps to travel 1 centimeter, and it takes an ant 3 steps to travel the same distance. We can track their